Well, hello guys, here Mr. G with another question for the grade 12 about the latest circuit. This time we're going to be solving a question in which is involved in internal resistance and obvious everything done up until now. This question states that in the circuit represented, the battery has an EMF of 24 volts. Now remember, this 24 volts is the EMF, okay? And the EMF is the total potential difference. Let's say the total voltage of the battery, but that one is when the battery is not working. So if the battery was not working, then it will have an EMF or potential difference voltage of 24 volts. As soon as the battery start working or is connected to a circuit, that 24 will drop to another number because there is something called internal resistance. So because there is internal resistance, that potential difference is going to be less than 24, the potential difference of the circuit, but the potential difference of the battery without working, or the EMF, is going to be 24 all the time. The resistance of resistor X is unknown as well. And here we have the circuit. It's a quite interesting circuit. You have a battery with internal resistance. That is important. They are telling you that there is an internal resistance there. This one here will represent the internal resistance of the circuit. You have a light bulb. You have a parallel connection here. Remember that the current could split here, but however, because this switch S is open, then the current initially only flow in one direction, which is this one. Okay, so that's what we have. And note the following, as we mentioned as before: when the circuit is measuring current here, the current is flowing through the circuit, the potential difference of this voltmeter here, this potential difference V must be less than 24 volts because there is an internal resistance. So that is important. The 24 volts is the EMF, but the V that is going to be reading here is less than 24, and this one is the external voltage or potential difference. That is very important. That is V load. Okay, that is what that voltmeter is going to read eventually when or it's reading already, but we don't know the number. If we go here, say when switch S is open, the ammeter has a reading of 1,5 amperes, and then let's real fast write this one. The current is going to be equal to 1,5 ampere, and that current is going to be throughout the whole circuit, for the internal circuit as well as for the external circuit. Remember last lesson. Now calculate the resistance of bulb L, if the power dissipated in it is equal to 18 watts. So they are telling you that the power dissipated here is equal to 18 watt. So we have that is 18 watt the power, and let's fix that. W is 18 watt, and we know that the current throughout the whole circuit, so the current also there is going to be equal to 1,5 amperes. We're looking for the resistance of that light bulb, guys, the resistance of that light bulb. Now if we go here, according to what we have, all the formulas for power are on this side here. This is for power, all the formulas. And then what we have? Well, we have power, we have current, and we're looking for resistance. So quite simple. That is the formula we're going to be using to solve this question here. Power is equal to current to the power 2 multiplied by resistance. The power is 18 volt, the current is 1,5 to the power 2. Let's fix those numbers there. 1,5 to the power 2 multiplied by resistance. Remember, I like to substitute within how the formula is allocated before start now rearranging the formula. However, if you rearrange this one, you have that is 18 divided by 1,5 square, and that is going to be equal to resistance. And the answer is going to be that the resistance of the light bulb is equal to 8 ohm. That is the answer for the very first question of this question 1 on electric circuit with internal resistance. This one is question 1.1. Let's just write it here, 1.1. Sorry about that. Now question 1.2, calculate the internal resistance of the battery. Well, now to calculate the internal resistance of the battery, we have quite a lot of formulas here to use, or let's say it's the same formula applicable in different ways. But now, because this switch S is open, guys, remember, because this switch S is open, we can have only one path for the current, so the whole circuit is in series. So if we do that, we can say that the total for question 1.2, the total external resistance, let's do this, external resistance is equal to the resistance in series plus parallel, but it's not parallel because the switch is open. Be careful with that one. So it's the resistance L plus the 6 ohm. That is the external resistance of this circuit, because everything is in series. We follow the current here in the circuit is going in this way, pass the light bulb, go there, but it doesn't have two paths because it's open, so only go this way there. That is the current, guys. I hope you understand what I'm saying here. So what I'm calculating here first is the external resistance of the circuit, and this one is equal to 8 plus 6, and we get that this is 14 ohm. This is the external resistance of the circuit. They want to calculate the internal resistance of the circuit. So what formula can we use? Here we have a formula which is Ohm's law for the whole circuit that can help us to calculate the internal resistance of the circuit. Because we have the EMF, we have the current, we have the external resistance. So using that formula, guys, which we are going to use here at this point, this is question 1.2, we can use the formula E is equal to I bracket R plus little r. And now the EMF is 24, is known by us. The current is 1,5 bracket. The external resistance is 14, and the internal resistance is what we are looking for. And this is simple math. When you solve, you have that 24 is equal to 21 plus 1,5 little r. And when you rearrange this one, guys, which is quite simple, is 24 minus 21 plus what's going on, equal to 1,5 r. And this one is quite simple. Let's just perhaps move it a little bit up so we have enough space. There we go. So now we have enough space here. So if we go on, we have that this is 3 divided by 1,5 is equal to the internal resistance. And then if we do that, then the internal resistance of the circuit is going to be equal to 2 ohm. That is the internal resistance of the circuit. And important, the internal resistance of the circuit is always going to be 2. At least the internal resistance of this circuit is going to be a 2 all the time, regardless if the circuit change in any way. If you don't change the battery, the internal resistance will always be 2 ohm here. So that is important to remember. Now, when the switch S is closed, the ammeter has a reading of 2 ampere. Okay, what is going on here? Now, in the next question, they close the switch. They close the switch here. And guys, what is happening? Now the current have 2 ways to flow. So when the current come to this point, split in 2 parts, and as a result of that one, obvious, then we have more path for the current to flow, and therefore the current will increase, and now the new current is going to be equal to 2 amperes. They are telling you that one in the question, so you don't have to worry too much. Calculate the reading of the voltmeter V. Okay, now that we know the internal resistance of the circuit, we can calculate the reading of voltmeter V. V, remember, is reading the external resistance and is going to be less than 24. Now, what do we know? We learned in the last video, we learned that the EMF is going to be equal to V load, or V external, plus V internal. Right, we know that one. We know that one is a formula. It's not given to you. It's like the addition of, or how to calculate the EMF. EMF is the total potential difference, and obvious will be the addition of V load or V external. Remember, this one here is V external, which is in actual fact what we are looking for. This one is external voltage, right? And this one here is the internal voltage. And guys, look here in the last video, here we are in the internal voltage. Here we have the way of calculating the internal voltage, and that formula we're talking about is just here in terms of EMF. We've done it last time, guys. It is there. Go back and watch the video, please. So now the internal voltage, can we calculate it? Yes. V internal, let's do it on this side here. V internal is equal to current, which is the same, multiplied by the internal resistance which we have. So the internal voltage, let's fix this word, internal voltage is equal to the current which is given to us. The new current after the switch is being closed is 2, and then the internal resistance, remember I said it doesn't change, doesn't matter how the circuit is going to change. So 2 times 2, it means that the internal voltage is 4 volts. That is quite simple here. So if we substitute this one in that formula there, we have that the EMF, which is 24, also doesn't change, is equal to V load or external voltage plus the internal voltage, which is 4 volts. So when we substitute here, we have that the dropping voltage or the load voltage, let's say, is equal to 24 minus 4 is going to be 20 volts. This is the external voltage of the circuit. So this is the voltage for the external part of the circuit. Is quite simple, guys. This one is question 1.3. Now question 1.4, calculate the resistance of resistor X. Now resistance of resistor X is on the parallel part of this circuit. Now the parallel part is working, the switch is closed, remember that one. We have the total external potential difference, we have the current, we have that this one is in a parallel connection here. So to answer this one, we have to do a little bit more work. This is question 1.4. Okay, so the first thing we're going to do is to calculate the potential difference across the light bulb here. That is quite important. So we can calculate the potential difference of the parallel part of this circuit. I'm going to call it in this way. We are going to do real fast that one. We have about the light bulb, we have the resistance. We cannot use the power because the power was done, the power dissipated, but that light bulb was under a different current. So we cannot use that power anymore. So we can calculate now the potential difference in the light bulb. Potential difference is equal to resistance multiplied by current, or current multiplied by resistance. It doesn't really matter, and the current is known to be 2 and the resistance of the light bulb is 8 ohm. So we get that the potential difference here is 16 volts. So now with that one, we can calculate the potential difference of the parallel part of the circuit. Remember, we are talking about the external part of the circuit. So we know that the potential difference, what is going on? The potential difference in the external part of the circuit is equal to the potential difference of the light bulb L plus the potential difference of the parallel part. This is all the external potential difference. I'm not talking about the internal part of the circuit. I'm working on the outside of the battery here. The potential difference external, we did calculate it, guy, and it was 20. That is the number that was used there. So it's 20 equal to the potential difference of the light bulb, which is 16 plus the potential difference of the parallel part of the circuit, and that one will give us, that is the potential difference of the parallel part of the circuit is equal to 4 volts. So 4 volts is the potential difference for the parallel part of the circuit. Important. So that means that if we go here, the potential difference here is 4, but also the potential difference across the 6 ohm is 4, and the potential difference across the resistor X is also going to be 4. So what we are going to do is the following. The current here gets split, but the potential difference is the same. If we calculate the current that is flowing through the 6 ohm resistor, therefore we have the current that is flowing through the X resistor there. So let's come here and say current through the What was that? 6 ohm. Current that flows through the 6 ohm resistor is equal to a potential difference divided by resistance. So if we substitute this one, potential difference is 4 because it's the same in the parallel part of the circuit. This one is 6, and then the current that is flowing through the 6 ohm resistance is equal to 0.66. Yeah, that is what I get in my calculator, 0.66. I'm going to write it the 7 amperes. And now the current that is flow through the X, guys, is going to be current through X. Very simple. We're almost done. The current that is flow through X is equal to the total current minus the 0.667. So the current that flows through X is equal to the total current, which is 2 amperes minus 0.667, and that will give you that the current through X is equal to 1.333 amperes. So, saying that, we may calculate now the resistance of the resistor X. And yes, this one is a little bit more work. Resistance is equal to current, what is going on there? Potential difference divided by current, and that is equal to potential difference to the parallel part of the circuit, which is 4, divided by the current that is going through X, which is 1.333, and this one will give us 3 ohm. This question can be done in different way. I recommend you to try and do it all the possible ways to practice, but the question is not that bad. Guys, this is the first question that we solve, which include internal resistance. I hope it helped. It's a little bit difficult, so stop the video, write notes, try to answer the question by yourself, and then mark the question. But thank you for watching. I hope it helped. I'll see you next time. Mr. G here.